this is. So the story today is about deep drawing. Deep drawing is about how we produce things like beverage cans and maybe scoops. Obviously it's clearly quite a deep shape and it's formed like that. So it's not a shallow stamping like maybe a car door panel, but it's a deep cupped shape. So a typical beverage can would start off as a disc of metal. So it might be something like this, and a punch will come down and push it into a die and form an initial first draw. So that's all we're doing here today, is the first draw. We're not going to do any ironing, which brings the sides up and creates the full height of the beverage can. So if we can get a disc such as this formed into a cup such as this, we will be very happy. One of the things we note that as we form the sheet into the cup shape is that the thickness doesn't change a whole lot. So if this is my blank and it's about just 9.96 is reading there, it doesn't get a whole lot thicker or thinner. It's okay, the very lip has got up a bit, maybe it's 1.1, yeah? Something like that. It hasn't changed enormously. So we can imagine that the process at a simple analysis doesn't change the thickness. So that enables us to do a calculation of, say we've got a particular diameter blank. This one is 60 millimeters in diameter, just 59 maybe, just short of 60. What height of cup would we expect it to produce? Inside in our die set here, this is our deep drawing rig. We have a punch attached to the top plate, a blank holder plate, and then the die will slip in underneath. So we slide in the die when we've got from the side here, when we've got the piece on it, yeah? So the question is, how far can we push it down? How deep a cup can we make? That's a calculation that everybody can do for their own diameter piece. So let's put this in and see what happens to our 60 diameter blank. So we have to slide it up and make sure it's aligned on the pin, and then screw the alignment pin into the die. Now there we go. Now we've got to check that the blank is sitting correctly located on the die. So after that, we're good to go. The first step would be to bring the blank holder plate down on top of the blank. So let's just do that. So manually pumping it, we can see it moving down. And no pressure coming up on the pressure gauge. So the pressure gauge above here allows us to measure the force that we're using to form the cup. So let's carry on from here. Well, you've done a calculation and you know that the 60 mil diameter cup is going to produce a certain height. But let's measure how much the plate travels down. So I'm going to set this to 0, where it's effectively starting the process, and go in 2 millimeter steps. So that was 0. Here goes 1.4, 2, 2.5, 2.6, and we already have 50 bar. .03, and we're at 85 bar. This is a lot of force. We can look at it in terms of the force required to burst the cup or pull the bottom out of the cup. So we may find that we don't get a successful part out of this because it's quite a large diameter. Our punch is, we'll go again, we'll see if we can get to 6. Well, let's take a reading at 5, if we can get to 5 even. Now, I'm taking minutes to do this. I've got to 5 and I have a reading of 110 bar. Okay, so let's go to 6. And 6.1 and a reading of 125 bar. Oh, so something bad happened there to the part. So at 9 millimeters travel it is there, but that's the whole thing has collapsed inside. So let's release it and have a look. So what have we learned from this? Well, you can't draw any size of blank. The bigger the blank is, the harder it is to get it to cup successfully. So we can see that the flange has been drawn in from the diameter 60 that it was. If we just took a measurement on that, we'd see it was 60. It's now 55, 55-ish all around, yeah? And it has gone down somewhat, but we had only, like if you took, we've only traveled effectively 5 or 6 millimeters, which is what we had as our measurement of displacement as a successful draw. And then the bottom, the nose of the part has failed in tension. So it's a tensile failure. We're used to measuring tensile stress, so we can look at the area that has failed and we know we can find out the tensile strength of the material, of the sheet, and expect to be able to calculate the force. Confirm we got the process under control, even though we have set it an impossible task in drawing at a drawing ratio of something like 2. So the diameter of the punch was 30 and the diameter of the blank was 60. That's very much at the limit of what's a practical drawing operation. A successful drawing operation might have, with a small blank, produced something like this with a full wall, or we might have decided with whatever our design intentions were to leave a lip on the top and just form a certain depth of cup. So that's a quick look at the story of deep drawing.